So my name is Susan Potter, and I am a software architect and engineering manager right now. And before that, I worked on high availability backend services and worked as a site reliability engineer. You can find me at GitHub as MBBX6 SPP, and on Twitter and LinkedIn as Susan Potter. And let's see, why is this not working to move the, sorry about this. Okay. Yes, so you can, that's exciting. Nope. Oh, sorry. Can you see this? No, it's screwed up here.
I see the slide.
Yeah, the slide is not moving forward, is it? No.
Nope.
Okay. Let me just restart with a different program. Sorry about that. Okay. Okay, and okay, so maybe it's okay, sorry.
There we go.
Sorry about that. So anyway, sorry. So I'm managing a small team. We have a large surface area, and if you want to endorse me for LinkedIn for some of my fire-eating or hating Jira with a passion, please feel free to. Yeah, so I manage a small team. We are quite stretched in terms of our responsibilities. And so we want to use tools that kind of front load our thinking, right? And we want to be able to, minimize the amount of firefighting that we do. And we tend to use, more functional approaches to things, from Nix to, why is this not moving? Okay, so from Nix to Doll and some, and Haskell previously. And now we're kind of using PureScript, right? So we do all kinds of things from, webhook endpoints, providing HTTP APIs, writing command line scripts for our developers, managing delivery pipelines, not just for our own projects, and also auto-scaling infrastructure. Yeah, so we started using PureScript last year, and just a quick overview. It transpiles to JavaScript, and it also has other compiler backends for written by unofficial sources. So you can also transpile to Erlang and Haskell, and sorry, not Haskell. Sorry, I don't know why I just said that. C++ and Go, sorry, very different languages. And it supports, algebraic data types, higher kind of types. It also supports, other things that are supported by GHC in the Haskell world, type classes, rebindable syntax, and functional dependencies. Don't worry if you don't know these things. If you do, then, I'm just kind of giving you a comparison of what's there. The unique features, or the more unique features compared to Haskell, in PureScript is row polymorphism and extensible records and variants, which is kind of built on top of that. And one of the nice things from an onboarding perspective, onboarding developers to our code base, is there's no more language fragments and a whole bunch of build tool setup that there typically is in the GHC world for Haskell. And the Prelude library is relatively modern, so it has a modern type class hierarchy. It doesn't have partial functions and things like that, which GHC legacy tends to suffer from a little bit still, even though they have been modernizing that over time. And so, yes, so we're going to try in this talk and solve common JSON pathologies with PureScript, right? And so we're going to look at two things first: how to compose codecs of smaller elements using PureScript, and how do we get sort of more descriptive decoding errors from that description, right? So we're going to start off with a subscription event, JSON. This is a very truncated piece of JSON from a Stripe document, developer document. I wanted to show nested records and the status thing, which is kind of like encoding an enum and some primitive types, right? So we can go ahead and start describing this type as a record. So this is what a record in TypeScript, PureScript looks like. We're just describing the fields that we see here and then annotating it with the respective types. Now, I've also provided two custom types, subscription status and invoice, and we'll see that those on the next slides. I'm going to be providing a link to the repository at the end and at the end in a public repository. I haven't made it public yet. Sorry about that. So we're going to be using some imports. Don't worry about this, but if you see a prefix to a function, this is where it's coming from. You can refer back to this in the slides that I'm going to share. So here, with the subscription event codec, we can just describe some metadata about it. Say this object is labeled as a subscription event. We're going to encode it as a record, and then for each of the fields, we provide a bidirectional codec, right? So it can decode and encode, right? And from this definition. And we've supplied two custom codecs here. So the Substatus codec we'll see on the next slide, and the invoice codec for the nested record on the following slide. You'll see here we're using algebraic data types. This is a very simple algebraic data type, but of course it works very similarly to how things, how you define algebraic data types in Haskell. PureScript doesn't support GADTs, GADITs, but there is a way of describing that in a different way, in a final way, right? But here, what we're doing is we're defining our own custom codec, and essentially we're just passing two functions, two simple pure functions to build that codec. So we're writing the encoder going from a substatus to a string, and then a decoder going from a string to a maybe substatus, because not all strings will map to a valid substatus. And this is, relatively simple, but being able to build this, new codecs is actually just as simple as providing two functions. Okay, and so to define our nested record, we can do something very similar to what we did in the first slide with PureScript code, or the second. And it looks relatively simple, and we're just utilizing that a new custom invoice status codec, right? And the benefit here is that we see that we can compose codecs together, right, at the appropriate point. We can reuse. That's great. And the invoice status codec looks essentially just like this, except for the cases of the invoice status. So yes, so we have, so we want to see what errors look like. So I've provided some invalid JSON. In this case, we have supplied an invalid subscription status. So foo is not a valid subscription status. So here it actually says at the bottom, we have this structured error. We can say the names, subscription event, at key status, unexpected value foo. So we actually get some reasonable, structured error from this. And so we in this case we are utilize I have an invalid type, right? So the ID field is actually not a string; it's a number. And so in this case, the error message actually comes back and it says at key ID of the subscription event, there's a type mismatch and it expected a string. So this is reasonably descriptive in terms of error messages. All right, so let's see what it looks like when it works. It does actually work. Yes, and so we are just getting back a write with the record. So in this case, we're returning an either, right? Because it could be an error or it could be a success value of a successfully decoded record. Okay, so what we've seen so far is we've shown how to compose, codecs, and we get descriptive decoding errors. Okay, so now we're going to look at can we have multiple JSON codecs for the same data? Why might that be useful? And then we'll look at partial decoding for delegation. So, so you might want to have different views for the same JSON for different reasons, or the same data. Integrating across multiple systems, you might have service A and B, but they see data quite differently. For example, a payment processor view of data, even if it's the same kind of data, might be quite different to the accounting system view. And so if, in this way, right, there are different ways to do JSON encoding, decoding. You can do it non-bidirectionally, so one direction, like at a time if you only need to decode or you only need to encode. That's one possibility. You can also take advantage of ad hoc polymorphism through type classes. One of the limitations with that approach is that you have to tend to tie that to the specific type. And if you want to have different representations, you'll have to have different JSON formats. For the same kind of data, you'll have to translate between lots of different data types. So you can take the data transfer object approach if you want to do a lot of translation between objects, if that as well. But in our case, we just have to provide a new value, a new codec value, bidirectional codec value, and we've got bidirectional encoding, decoding that will be symmetric for our needs. So remember this JSON. In our case, we might actually only want to peek into the object type field so that we know how to direct it or how to delegate it to the appropriate persistence function. And so, we can just define a very simple object codec, which or event codec, I probably should have called it, where we are just trying to decode the object field only. And for all of the JSON examples that I had, even the invalid ones, we are able to peek into the object field because all of them had an object field. So at least we can actually inspect what's going on or try and decide how to direct traffic if we need to. So as a way to do this, we can leverage extensible records, or we can. So here we've got a persist subscription, and it is a function that takes a JSON parse tree or AST and produces produces an effective unit. Similarly for the persist payment. So that's where we're actually persisting to the database if we needed to. In the handle event, let's see if I can draw on here so that I can so we've got handle event. This for all R. We're putting kind of a placeholder here, this R, and it can be any R for the rest of that record. And we're saying we just don't care about what other fields are in there. We are requiring a JSON structure, right? And then this object, as long as it has an object field, we don't care about any other fields that exist in that record for the second argument, and then we can produce the effect unit. And if you're familiar with Haskell, there's many different ways of trying to do extensible records in Haskell, and not at the language level. This makes it quite easy to just express the intent here, in my opinion, right? Okay, so let's see. Let's go. Let's erase this. Yes. Okay. So here we've got describing. Yes. So we can also describe our events in an extensible record way as well. So we could define this. This should not be there. Sorry about that. There is an error in my slides. Sorry, just that shouldn't be there. This should just be a record where we are inserting the rest of the payload rows that we pass in as a parameter to the type, and just kind of appending it on, right? So here we've got a type sub, which is short for subscription. We are going to type alias it to an event that we extend with two fields, status and last invoice, right, with their corresponding types. And so this is effectively equivalent to a record that has 4 fields, right, at that point. Yes. So what we've looked at is multiple JSON codecs for the same data, different views, being able to inspect partial decoding so that you can route it appropriately or delegate, and partial decoding. Yeah, sorry. And then doing the partial decoding for delegation. So so now let's have a quick look at how we can utilize this small library that actually uses quite a number of the PureScript language features to do things like defaultable missing fields. So sometimes you'll be dealing with JSON that has missing fields, but there are valid defaults that you want to use, right? You want to have in your your object representations. So let's have a look at that. So the magic all comes from this combinator, right, which basically takes 2 of these codecs. So under the hood, JSON codec, which we've seen on previous slides. Let's see if we can quickly. Yeah, so on the top here, object codec, that's of type JSON codec of something, right? And so it's taking 2 JSON codecs. This is kind of how it translates under the hood. And you'll see here that it's relying on higher kind of types, right? We're passing in type constructors as arguments to G codec. And so it's taking 2 of these JSON, what JSON codec looks like, JSON codec or something looks underneath the covers, and then it kind of merges it into one, right? So okay, so don't get too worried about how many for alls there are there and what everything means here. Just know that it's taking 2 of the same thing and then merging it into one of that same thing, right? So here we want to be able to add members default field with an empty array, and we can do that by saying add default field, the name of the key, members, and then the JSON value that we want to insert into that JSON structure before it actually gets decoded through, and then we merge it, if you will, with the old codec, right? That might actually expect a members field. And so some other things that are annoying to deal with, right, with JSON is defaulting nullable fields, right? So sometimes you'll want to be able to add some kind of, yes, you want to have some field where, it could be a null or it could have a value, but it's always going to be there. The key is always going to be there. In this case, we're just using canned maybe function that combines with another codec, so that we just get a new codec out of it, right? So this maybe, the CA maybe is just a function that takes another codec and then produces a new codec to express that, right, to encode that. And another case is like renaming a field. So if you're building Slack apps or something like that, Slack changes their JSON representation now and then. So they might change or rename fields, or they might actually just eliminate fields. So here we can just say we're going to rename, if event ID exists in this JSON structure, then we want to rename it to ID so that the old codec can then give us what we're expecting, right, in terms of our decoded value. And so here I've had to deal with a lot of enterprise APIs, and one of the exciting things that I've had to deal with is where they would send over a Boolean as a string, but really we want to represent it as a Boolean inside of our data type, instead of having to do nonsense at the edges of our logic. So here we can just update the isActive field, and we provide a function that takes a JSON and then produces a new JSON type, right? And so here all we're doing is we're saying if the JSON is the string true, then we can just return it as a JSON true, right? And then if it's anything else, then we express it as a JSON false. Anyway, so this kind of makes working with JSON from multiple vendors, especially enterprise third parties that don't really think about data formats this way, a lot more, a lot saner, right? And it's something when we come back to this kind of code 6 months later, it's helping us articulate our original intent a lot more clearly. And so anyway, let's kind of review what we've looked at so far. So we directly used features like algebraic data types, extensible records potentially, depending on how we encoded our event representations. And then, of course, we used higher order functions everywhere. That's kind of part of parcel for functional programming. But under the hood, this library kind of leveraged row types. There's a couple of places of functional dependencies, and functional dependencies works with multi-parameter type classes, where you can say, oh, if we know the A and B of maybe two of the three type parameters, right? Parameters to the type class, then we can infer the third one, right? And then the creator provides the relevant instances, so that the type checker can actually resolve that. we also leveraged under the hood, of course, through this library higher kinded types, and to kind of be able to give us the properties that we were really looking for in a bidirectional codec. We also implicitly, or the library implicitly, used ad hoc polymorphism via type classes, and very minimally there is a way of using generic representations for deriving instances as well, which could have been used, but we didn't directly use that in this case. But yeah, I mean, PureScript kind of offers kind of like a variety of these kind of nice little features that allow us to build applications in a way where we're clearly, or more clearly, I should say, expressing our intent, such that when we return to it, 6 months later, it's so much easier to maintain and pick up and start going from where we're going. Yeah, so I'm happy to talk about to have questions. Sorry, let me see if I can go back to the Q&A. Oh, how easy is it to use NPM packages with PureScript? It's very easy. We use NPM for the bringing everything from the Node ecosystem together. So we NPM install, of course, and all of that sort of stuff. And then for the foreign function interfacing, there's a couple of small rules in terms of like, to kind of make something an asynchronous, an async, action. You have to like provide a wrapper function in JavaScript that contains, a certain type signature, so that it can convert that nicely and things like that. But other than that, it's relatively simple, especially if it's just simple functions that you want to interface with. Yeah, sorry. And so, yes, and we use it. Sorry, go on.
And I see a bunch of questions getting on. So if you're asking questions, feel free to raise your hand, and we can invite you on the virtual stage as well as Susan finishes wrapping up that other question. So if you want to ask it in person, raise your hand and we can let you ask it there. Cool.
Yeah. And we, for example, foreign function interface to, I've forgotten what it is, PG promise, I think it is, for Postgres. And it's just like fairly simple, function wrappers in JavaScript, and then just the foreign declarations in the PureScript module. And then as long as you get the format just right, it works quite well. So how do you how do you deal with a possible spaghetti code when you start to put all this extra decoders or encoders that deprecates your input and outputs? How do you deal with a possible? Well, because these codecs are built like in a compositional way, like we can organize them, in a way that makes sense to us. And then we just, compose the appropriate codecs. And if we no longer need those codecs, then we can just remove them from the code. So, I mean, yeah, like for the purposes of this talk, I kind of inlined a few things, right? More than I probably would have. But yeah, so, I mean, because it's because these are like composable things, they don't depend on external state or anything like that. We can just organize our codecs however we want. Now, there is a way to generically derive JSON from data types in PureScript. We don't do that because we need different views into the same data type, and that's our preferred thing. We don't like the automatic change to our JSON encodings or decodings just because we've added a new field, and that's kind of by design so that we can have multiple versions for things. I hope that answers that question. Oh, can you list a few of your favorite PureScript language features that you miss in Haskell and vice versa? Yeah, I mean, I really miss the power of Haskell and the potential performance that you can get. We're limited by the JavaScript runtime right now. We are actually looking at transpiling to Go to see if that can help us on our serverless functions. Yes, we are. Yes, so I do miss the ability to do more things, but I really like the simplicity of PureScript from an onboarding perspective. So we can, row polymorphism is kind of amazing for me personally. So with Haskell, there's GHC, is amazing potentially. Like if you can tweak the build and everything, you can do some amazing things. You can do crazy things with, call by need, right? And get some extra, deforestation sort of things. Anyway, so those are the things I tend to miss. So what did you use for JSON handling before the solution? We were writing in TypeScript for that, for this part of things. And that was very just ad hoc, lots of imperative code to translate, oh, does it have this key? If not, then we'll do this, we'll add this thing. So it's just a whole bunch of glue code that doesn't compose. And so that's kind of how we got into that. And then, is there a relationship between these codecs and lenses? Oh, yes, actually there are. That's a great question. So under the covers, we're using the codec, data codec library uses, I think, a specialization of profunctor called star, I think, as well as some other things. And in PureScript, the lens library or the optics library is based on profunctors, which is one way to encode functional optics, right? From lenses to prisms to traversals and what's the other one? Folds, right? And things like that. Yeah, cool. Thank you. Yeah. Any other? Oh, there is one more. What are the advantages PureScript and transpiling it to Go versus writing Haskell directly? So we found, I found, I should say, onboarding our developers who are previously JavaScript or TypeScript developers to Haskell a little harder than to PureScript, right? And in part because GHC's, build complexity, but also because of so from a performance perspective, there's no. I think probably we could tune GHC to have higher performance, maybe in some cases, right? Depending on what we're looking for, right? But yeah, it's not about performance per se. It's just comparing Node.js runtime to Go. Hopefully that satisfies that. Thank you.
So I'll ask one while.
Did I miss anything?
I'll ask one question while we wait for anybody else to come up. I think we've answered all the ones in the QA. So if anybody else wants to raise their hand or add another one while I ask. But you showed an example of peeking into those structures. So you said, hey, what kind of event is this? I want to peek into this in dispatch. Is that the same kind of thing you do with versions on APIs? If you get a payload down and say, hey, this is a version 1 API and this is a version 2, you dispatch appropriately that way by peeking in?
Yes, yeah, totally. Yes, so versions, yes. If it's not in the HTTP headers, yes, that would totally be what I would do, right? Exactly. So in this case, it's just about, because the object can be a subscription or a payment or something like that, and the way in which we persist, and we might persist to different data stores, for example. So that was the example there. But yes, it could easily be done for different versions of an API. Yeah, thanks for that.
I guess the other question would be, you could peek in, could you do alternate decoders and say, here's decoder V1 and here's decoder V2, and let it pick whichever one succeeds?
Oh, you can. I'm pretty sure you can. I think there's an alternative instance. So you would be able to do that. I'm pretty sure. But yeah, so I think you'd be able to do that. Don't quote me on that, but I think so. And then, but also, like, if you wanted to peek in just to know for sure, like if there's a field that says, hey, this is V1, V2, then you can, but yes, if you wanted to degrade gracefully to like a V1 or something, yeah, I think that is actually possible. Yeah.
And then we got a couple more questions come in. So Martin asked, did you consider Erlang as a backend with PureL?
I didn't, and I do love Erlang, right? I've worked in Erlang before, and what happened? Yeah, I think when I first joined, I suggested Erlang. We did like 2 proof of concepts, and for whatever reason, I don't recall the rationale now. But we went with Haskell for the backend pieces, not this this JSON integration thing that we took over. And that's where we kind of had some stumbles in terms of onboarding, not the Ruby developers, interestingly, but the JavaScript developers. So that's kind of where we're transitioning, kind of partly from Haskell to PureScript for that reason. And one more, do you have inside the team some people that came from Pure.js world to PureScript? Yes. So I'm the only one that had previous, Haskell or anything like that experience. We have someone who's very JavaScript, experienced, and then someone who is much more infrastructure oriented on the team. Hopefully that answers that.